Hi, in this video I want to talk about a variable that I built in C. But before that, I know I haven't uploaded any video for a long time and I just wanted to rest a bit, and I assure you that continue uploading videos. And in this video, I wanted to talk about again variable that I built. Now, unlike Python, C doesn't have a flexible variable where you can say a equals to 5 and then say a equals to a string. To overcome this issue, I have developed my own variable. Yeah, it's just basically a structure, and this is basically the whole variable, and I use some helper functions to assign values to my variable. So let's see the first parameter, character current ID. So basically this current ID holds the current data type that we are storing. So for example, variable dot current ID equals to I, meaning we are storing an integer. Variable dot current ID equals to S, meaning we are storing a string. So yeah, we basically upload that based on the variable that we are storing. And the second one is unsigned int max size. Now this is tricky. In Python, when you say a equals to 5, you don't declare the length of your variable, whether it's like 4-bit, 8-bit, 16-bit. In my own variable, I want to cap my variables to some value, and for that reason I have created the max size parameter in my structure. So let's see how to use it. Now we are using this define variable function to define our variable, and in this function, as you can see, we are getting a max size, right? We are getting current ID, the data type of our variable, and max size. And then we allocate some space in memory using this max size. And this basically caps our variable. So if you say max size is 100, you cannot have a string that is bigger than 100 characters. That is what this max size is responsible for. It caps your variable to some value, and we needed to define our variable too. Okay, and then we have unsigned int current side. Well, this is pretty straightforward. What is the current length of your variable? If you're storing an integer, your current length is 4 bits. No, 4 bytes, sorry. If you are storing a character, your current length is 1 byte. And then we also have void variable and char local. Now, what are these? Because I wanted my variable to be flexible, I needed to store integers, strings, floats, and every other data type in a single variable. And for this reason, I have developed this char local array. And this array is basically where we store our integers, floats. And the way it works is, let's see the function. So we have a helper function called as let's see, set variable, as you can see. So the way set variable works is that, let's see, set variable oops, I think it is defined in somewhere else. Yep, it's defined here. Oh yeah, because okay, I remember it now. So the way set variable works is that you have two inputs: your your target variable that you want to set your variable to be, and your address of your variable. In here, for example, we create a variable called as a, and we use the define variable function, right? And then we assigned it to be an integer by in the beginning, and we gave it 100 as a max space, so we cannot have a string of 200 characters in this variable. Okay, and then we set our variable to be 15.55555566666, and then we pass our address of our variable. And when we write set variable, this function is invoked, right? This set variable, and then it, as you can see, accepts two variables, and we use a specific notation in GCC in C interpreter that looks at the target, right? Target is this value of 15.5566 whatever, and then we classify it based on the data type. If the target is an integer, we are saying that invoke set variable int. If the target is a character pointer, then invoke set var character. If the target is a float, then invoke this function. So that's all this piece of code does. And let's see, for example, what is this? Let's say this is a float, and then let's invoke float set var float. Okay. Now let's see set variable float. Again, we get a target float target, which is 15.5566, and we also get a character, our variable pointer, which we set ampersand a here. Cool. And what do we do in this function? We say current variable current id equals to f, because right now our character is a float. And then we set variable local to be our target. What is variable local? Now, in our definition, in our structure definition, we have variable, which is this thing, structure, and the local is this character local with 24 bytes in stack, allocated in stack. And then when you say variable local, we are updating, we are basically changing the value of variable local to our target. And then we set variable current size equals to size of float, and then I put like a null stop at the end. This is not needed, and this is also a bad practice too, but I just put it for kind of no reason. So basically we updated our variables local, right? And when we are printing our variable, which is, as you can see, we then say invoke print variable a. So when we call print variable and pass our variable here, it checks the current id. Is it integer? No. Long int? No. Long int? No. Long int? No. String? No. Float? Yes, it is a float. And then we call printf %f, and then we call variable dot local. So we are basically getting the value written in local, like this this memory block. We are getting a float from there. As you can see, we parse it to a float. So we wrote float to this memory memory location, memory, I don't know, memory space, and then we get a float amount of bytes, like the size of float amount of bytes from that memory location. And that's basically the main idea. So let's continue. And then we set variable 22. So we again invoke set variable, right? We pass 22. 22 is an integer. Then we enter the integer one. Let's see, set variable integer. Here it is. And then we set the current id to be an integer. Then we set the local part of our variable, local instance, I don't know what to call this, local part of our variable to be target, and it is obviously an integer 2. And then we set the current size to be the size of our integer, and null stop again. This is not needed, but I put it anyways, and then we return. And when we are again printing our variable, we invoke the print variable function here. Let's see, variable current id is an integer yet, and then we enter this block. We grab an integer, the size of integer amount of bytes from variable.local, which we declared here, and then we print that variable out. Oops, I closed my, oh, here it is. Now moving on and set var AAA, which we assign strings, right? Now strings, Again, we enter setvar. This is a string. We invoke setvar character. In set variable character function, we first set variable current ID to be s string, and then we get the length of our string. Then this is where things get complicated. We say if our length of string is bigger than or equals to 23, if we cannot fit our string into this 24 bytes local space. I'm gonna delete this. Okay, if we cannot fit that into 24 byte local space, then we use memory copy. We use variable var. Here we declare it, and then we basically write it to this variable var space, and then we write target to that variable var space, and we write len amount of times, and then we stop with a what is this called? Not stop, but I forgot this name, but we basically end our string here. And then we obviously update our current size too. Else, if our length of our variable is less than or equals less than 23, then we copy our target to variable local. So we copy it to this local memory buffer that we created. And then we again add a null termination. Okay, I now remember its name. And then we always update the current size. And when we are printing strings, right? When we are printing strings, we say if the current size is bigger than or equal to 25, then print it using this format, but we are printing it from var, right? From here, because it's bigger than our local buffer. If it is less than 25, then we print it from local because it successfully fits here. And I just realized something that I deleted. Actually, I thought it was an error, but it wasn't. Now here, I accidentally deleted a foolproof mechanism. We remember we set like max size, right? In the beginning of our code, we set max size. And we also need to check if whether length is bigger than or equals to this max size. If that is the case, then we need to take only specific amount of the string that is below max size, because we, while defining our variable, we set a max size right here. We cannot we cannot perform overflow, so we need to be careful about that. So that's basically it. Let's actually compile our program. I guess this, yep, and then my project.exe. So we expect to print 15.5566 whatever, then 22, then a, right? Oops, and there we go. This, and this. The reason why it didn't print sixes is because I think there was something with floats and doubles, so like it basically rounds this up, right? I think that's the case, because if I put more fives here, then it should be a different outcome. It isn't. Okay, so I don't know why. That's something mysterious about C, that like, yeah, there's something wrong about float point numbers in programming languages. So whatever, that's basically it. In this way we are able to make a variable, and then we can store multiple data types in this variable. Cool. So that's all for this video. If you have any questions, please leave a comment, and have a great day.